Hi, I'm Stephen Hevern. I am a Senior Technical Account Manager at AWS, and I'm based out of Philadelphia, Pennsylvania. Welcome to AWS Supports You, where AWS support experts provide tips to optimize performance in the cloud, lower costs, and provide you with best practices and design considerations. Joining me today is Werd Kusin from AWS Support. Werd, can you give us a quick introduction?
Yeah, Stephen, hi. I'm Werd Kussens. I'm working as a solution architect with enterprise customers here in Belgium.
Awesome, thanks. Today, we'll be introducing you to implementing infrastructure as code using Python. We will specifically focus on CDK for provisioning of AWS services. Before we get into the details, quick note for the attendees online, use the chat window on the right-hand side of your screen to let us know where you're joining us from today and share your thoughts and questions throughout the episode. We look forward to hearing from you. We will also provide a link to our survey. So if you'd like to let us know how we did, please click the link and provide your feedback. Werd, can you take it away?
Yeah, thank you. So let me start with a bold statement. I think that the maturity of the tools that we use today to configure our infrastructure is not up to the level of the tools that we use for programming. Maybe we can have a look at the history of both infrastructure and software development to explain that a bit. So the picture you see here is a picture of one of the first acts of programming. The person in the middle is Grace Hopkins. She's programming a computer to calculate the biggest prime factor of the number 2 to the 18th power. This was about 70 years ago. And since Grace Hopkins entered this program, lots of new development has happened in this area. For example, a few years later, the programming language Fortran was developed. And built on top of that, many other languages came. And with these languages, new paradigms came. And with these new paradigms, new ways of thinking about solving problems with programming came. Also, there was a lot of support built around these programming languages. Things like tools, compilers, linters. It's all been developed in the last 70 years or so. The history of infrastructure is started slightly different because for the longest time, infrastructure required a very physical act as well. There was a need to move boxes from A to B. You have to open the boxes and get what was inside out, put it in a rack, maybe connect it up with cables. The room had to be controlled to a certain temperature, had to be physically secured as well. People had to be trained to do that. So the development of the tooling around provisioning infrastructure came from a very different place. Also, it was much more expensive to just install a new computer. There was a very big purchase that needed to be made, and that made that companies were much less willing or much less able to experiment in these processes. So many companies developed long processes to make sure that the right hardware was procured and to stop wasting money. So these kind of processes are still living with us today, but made it, of course, much harder for infrastructure to develop the tooling that was able to develop around software development. It's much less experimentation, much harder to experiment. Now, fast forward a few years. In 2007, AWS, Amazon at the time, introduced one service called SQS that enabled customers to use a piece of infrastructure without buying the hardware, without provisioning something physically. They allowed their users to just use an API or a UI and start that piece of functionality, use it for as long as they wished for, and then stop using it without paying for any provisioning and all without paying after they stopped using it. This was a fundamentally different way of thinking about infrastructure, one that has no physical component anymore. Since then, a lot of services were added, and what you can see here is around the 200 services that are offered today. Each of these services is replacing, in a very specialized or a very generic way, a piece of physical infrastructure that had to be purchased and had to be installed at some point in time with a totally virtual experience that can also be completely without any physical aspect, be provisioned and be shut down again. This, of course, allows for a lot more of experimentation, and a lot of different tools were developed around this new, let's say, way of working for infrastructure. These tools you can think of in 3 levels of abstraction. The lowest level is the manual level, where people would still go and do a few steps. They would just not involve any physical activity. So people would go into the UI, click on Start New Server, automatically manage the network for that server, and do all the steps that were needed to provision their infrastructure, just not with a physical action. I mean, except for the clicking of the button, of course. After that, people started documenting or documenting these steps so that it became a bit easier to repeat them in wikis or internal documents. But when something really bad happened, there was still a lot of times where you needed to find that one person that knew how to get this infrastructure up and running again. This is the Ask Jenny, she knows effect, or the Ask Bob, he knows, or whoever. But the fact that you still are very dependent on a few people who knew how to do these steps. To get rid of this problem, or to help solving this problem, there were tools developed that made infrastructure available as code. So you could now, as a team, develop a text file, like a code file that you did for your application code, that perfectly described what the infrastructure should look like that you needed to run your application. These tools, there's quite a few of them. Terraform is a very famous one. There's Chef, Puppet, Ansible, and there's also the one that AWS developed called CloudFormation. All of them have a very declarative syntax. They basically allow you to write in a text file in great detail all the different components of that infrastructure that you are requiring for your application to run. There is then an application that will take these configuration files and turn them into real virtual hardware in the cloud, for example. This was a great step forward, but still it is a totally different way of thinking about a problem than it was software development. In a previous life, I was a software developer, and I was very proficient with languages like Java, Clojure, JavaScript. But I remember clearly that at the time when infrastructure as code was introduced, for me, my first reaction was yet another language, yet another thing to configure, yet another tool chain to master, yet another thing to explain to new people who join the team, yet another thing to get into documentation to find all the details when it goes wrong. And that's where I think that the next step here, the next logical step, is actually, instead of infrastructure as code, infrastructure is code. And that is exactly what CDK is offering us. CDK is a different way of approaching infrastructure definition as code. It basically is not a separate language. It is a library that plugs into an existing language. It's available in 6 different languages. There is support for Java, there is support for .NET, so C#. There is support for Go, Python, TypeScript, and JavaScript. So if any of these languages are familiar to you, you can basically keep on using that same language, just import a library and start developing infrastructure next to your application code. This has a few advantages, and I will come back to the advantages later. It is also by now being used as the de facto standard inside AWS. So this is a screenshot of my editor while editing some infrastructure as code definitions. As you can see, it looks very much like any normal application code. There is a class definition there, but more importantly, it is just a normal Python file. And you also get all the nice things from the support from the editor that you would get while developing normal Python code. You can see there is a pop-up showing me what kind of methods are available on this object. And there is also inline documentation. All of these things you are used to from the Python development experience while writing software is now also available to you for developing infrastructure. So why would you use CDK? First of all, again, like I said, it is the same tools for infrastructure as it is for developing software. It's one less thing to keep in your head while developing software. It's one less new thing that people that join the team have to learn. It's one less tool chain that you have to set up, one less way of handling compiler errors. It's all bundled in that same language that you already use. It reduces, as such, it reduces the number of tools, and it gives you the same level of tool support, like code completion, compiler type checks, that you are used to from your normal software development experience. If you use a language like Python, you might get hints, but if you use a language like Java or TypeScript, you will actually get very strong compiler support for things like type checking. But for me, the major advantage of CDK, and the one thing that is really setting it apart from more declarative languages like CloudFormation, is the fact that you can abstract your infrastructure, because you're not just using a programming language as a way to configure your infrastructure. You're using all the concepts behind it that are available to you for abstraction as well. Things like inheritance can be used now to wrap or to combine different parts of infrastructure together and to distribute them as a single thing, to enable your teams to talk about constructs as a whole, as a more abstract entity than if you were talking about them as all the individual components. Giving this abstraction, it's also much easier to share these constructs with the wider world. It could be inside the organization, it could also be outside the organization. So it allows teams to think in a more abstract way about their infrastructure, and not focusing too much on the individual components, but rather look at what you're building with it, how it is built together, and then shipping this and sharing it inside the organization. So CDK is organized in such a way that allows the users to think in 3 levels of abstraction. The lowest level is very similar to CloudFormation. It basically allows you to create constructs. We'll come to that later, but to create constructs that are more or less one-on-one mapped to CloudFormation constructs. So if you write CDK like that, it will just be like CloudFormation in a slightly different syntax. You will get some advantages, but you will not use the full power of CDK. If you're in the second level, you start wrapping these constructs, maybe bringing a few things together, providing some sensible defaults for your setup, and then start sharing a bit more higher level constructs. And that's where CDK starts adding more value. So say, for example, that a level 1 construct could be an S3 bucket, a plain standard AWS S3 bucket. This would be a simple thing to define. But it might, for your organization, might not be enough. Maybe you have some policies, company policies that demand that you put a certain protection in place, a certain security group maybe, or you block public access. You could add these things on top of the standard S3 bucket, and then wrap that in a construct that you now use as if it were an S3 bucket, but it's adapted to your situation. So you can stop thinking about all the implementation details, so to say, for a company-specific S3 bucket. You could just take it as a storage bin, or whatever you want to call it, and pass that on, share that, and use that now for in any case where you would actually normally need an S3 bucket, and you don't have to add all the steps that you would normally have to do. That's what the level where we call curated components. If you combine these components into even a higher level of abstraction, and you think about the infrastructure not just as a collection of components, but as something that solves a business problem, then you're thinking about level 3, and that's what we call the patterns. So on a pattern, you could think about, for example, an API. An API will actually contain quite a few components. It will contain an HTTP part that will handle the request. It will also contain some logic that's used to generate the responses. Everything in between has to be wired up. All these things together could be very different depending on your company setup. But these could all be packaged together and could be used to could then be shared over the different departments of your organization, so that you have some kind of unified way to define an API. And this is where CDK really adds value, because it allows you to think about this higher level of abstractions, to say. So let's dive a bit in these concepts here. The lowest level in CDK, or the most fundamental building block in CDK, is the construct. And the construct is, for example, could be a Lambda function, or it could be an S3 bucket, could be a DynamoDB table, or it could be anything that you can also define using the UI. These constructs can be combined and then deployed as a stack. So a stack here is a single unit of deployment. A stack can also then be deployed independently. If you have multiple stacks inside an application, each stack can be deployed independently. So the application is the combination of all the stacks. All the stacks are composed out of different constructs, and the constructs are the things that you define within your organization, and you can use to reason about and you can use to share. Now, CloudFormation comes with a console application, a CLI. Sorry, CDK comes with a CLI that compiles your CloudFormation code that compiles your CDK code into CloudFormation template. And this CloudFormation template is then deployed to AWS. And inside AWS, the CloudFormation web service is used to provision these resources. Maybe, Stephen, are any questions at this point in time around the presentation so far?
Yeah, we've got a question from JibJabo6. They'd like to know when to use a different stack.
That's a very good question. So it's the fundamental thing here to realize is that stacks can be deployed independently. So if there's inside your application parts that you would rather deploy, let's say, more often, like the code that is running on your backend, this could be deployed independently from things that you might not deploy that often, like your database servers. So think about speed and how often things will change together, basically, a bit like the way microservices should be cut. So if you think about it like that, it becomes clear where you could use that as a guidance to know where to cut your stacks.
Cool, thanks. Don't have any other questions, so carry on.
All right, go to the next slide then. So if you think about infrastructure in this slightly higher abstraction, you can start building libraries of components or things that you can then share within your organization. And I have seen quite a few customers that built this internal library of ways how to solve business problems with CDK. So has a huge example, a huge advantage for teams that are starting out, and they can just build on top of what other teams have already discovered or already built. And it also allows you to put some kind of governance in place, right? You could say this is the best practice for our organization to do APIs, for example, just to take the same example again. This is the best way that we found that our organization wants to do storage in S3. And these things can then be shared. And then this could either be shared as in a way where there is a different team owning each of these components, or it can be shared where teams are working together on these components. There is a lot of inspiration there you could take from the open source community. And of course, if you share these things, it's not just about giving, you can also use what is already created. So there is, for example, a construct library in cdkpatterns.com that you can visit and see what other people have built with CDK, and then also import that inside your application and build on top of that. The patterns that are there are very diverse. There is, for example, one that allows you to add monitoring to quite a few components. So you could just pull in a construct from cdkpatterns.com, add that to your application as a stack, or maybe add it to a stack that you already have, and then you can start adding all of these things to, and you can start adding monitoring for all the other components in your stack. So next, I would like to touch briefly on best practices, because of course it might be the same language. It doesn't mean that you can treat it exactly the same as normal programming. It's of course a different different setup, even if it's the same language. There's definitely best practices there that you should be aware of. So first of all, and I think nobody will be surprised about that, you should version your code. This makes it much easier to roll back if something went wrong. It's actually one of the great advantages of using infrastructure as code. By defining everything in a text file, you can use all these nice tools that are available for text file versioning, like Git is probably one of the most popular. Once you have it versioned, you should also think about continuous integration, even continuous deployment. It's more almost become kind of standard practice for software development, but I think it works very well for infrastructure as well. Of course, CI/CD, you cannot just do that without any support there. So testing is, for example, very important there. For testing, you could think about linting, which is not really testing, of course, but it's another quality check. There are some nice tools out there. CFN NAC is an interesting one. There's also CFN check, which are basically codifying best practices in a way that you can run them against your CDK code and get warnings if something would be, for example, an obvious security issue. And these warnings can then either be ignored, because sometimes this is the way we do it and there's no risk there, or they could stop the pipeline. And in case your test coverage is good enough, you know that once the test is passed, the actually new version of the infrastructure can be deployed into your environments. Then, of course, after you deploy to the environment, there should be some additional testing. A really cool pattern there, I think, is the blue-green deployment, where you deploy a new version of your application. You start testing if that new version is performing as expected. If not, you roll back, and if it is, you start gradually deprecating the old version in favor of the new version. I think also CloudRec mentioned here that smaller stacks could be used for testing. I think that's a great idea, because indeed a shorter time to deploy. You could basically select a subset of components to deploy and put it in a stack and test that immediately. That sounds like a great idea. I haven't personally done it yet, but it sounds like a great idea. Another question that I see here is that Amplify hosting. Can we do something that mimics Amplify hosting? There, I'm not 100% sure what the question means. Maybe if you could clarify it a bit, because CDK is actually pretty different from that, right? You could construct something that does hosting for you, but it's quite different tool. It has a very different use case. I think it's basically defining how to do the hosting. It's not something that hosts itself, so to say. Okay, so for the best practices, another very important thing that you have to think about as a team is SLOs. And with SLOs, I mean service level objectives. So these are not SLAs, so there's no agreement here. There's no service level agreement, not something that you put inside the contract or that you sign with your customer, that you might have some liabilities if you don't meet them. Service level objectives are things that the team themselves define and that they can decide then on whether this is something that they can achieve or not. It is something that you should define together with technical and product people and have an agreement on, because objectives will be both functional, like we have to load the overview page when people go to the overview page, for example, but there will also be non-functional requirements, like the page should be loaded in a few milliseconds or should be up most of the time. And if you have these SLOs defined, you can also automate checks and make sure that the application, the new version of the application that you just deployed, the infrastructure that you just deployed, is actually still meeting these checks. The very important topic here also is the concept of least privileges for deploying. What this means is that you will have a user that will be used to deploy your application. It will most likely be a user that is that is created only for this purpose, or a role that is created only for this purpose. And you should try to limit the permissions that this role has, so that it only can do the deployment of your application. And vice versa, ideally, you think you might have a setup where only your code pipeline, so the thing that runs your checks and runs your deploys, is able to assume this role. No human can ever assume this role except under very, very big exceptional circumstances. If you have a setup like that, you can be sure that the infrastructure as code definition will match the environment that has been created, because only that one role can deploy to that account. And the only way that this role is being assumed is by using an automatic process that takes your infrastructure as code, runs your tests, and only if they are successful, moves that into production. Another one for around security is that you can use CDK to do some checks, for example, testing whether a certain S3 bucket is reachable, but you cannot use CDK for enforcing security. For that, you should use the native mechanisms like IAM or security groups that are built into AWS. The deployment of your application, if you have defined it in infrastructure as code, becomes much easier over different regions and different accounts, because you have the same definition that you can now deploy to two different accounts or to different regions or even more. And that allows you, of course, to have test environments that are very close to your production environment, and also to deploy in a multi-region setup that makes your application more resilient for failures. This was a short introduction. Now I would really like to show you a bit in a demo how developing a infrastructure as code project using CDK works. But before I do that, are there any questions in the room?
Thanks, Ward. From the ones you already answered with Rudy X World and CloudRec, I'm not seeing any other questions at the moment coming in. So if you want to go ahead and jump into the demo.
Sure. Let me start the demo here. So what you'll see here is an instance of Visual Code editor that I use for normal Python development. And I start out this demo starts out in an empty folder. This always is a good start for a project, and it's also a requirement for a CDK project. The first command that you will do to start a CDK project is the command cdk init app. Now you can specify the language with the flag language. In our case, for this demo, we'll use Python. Running this command will create quite a few files. You'll see them appear on the left in the browser, and you also see some output here. Apart from the normal code files, there's also some virtual env environments that are being created so that you know for sure that the Python that you are using is the right version and has the right dependencies. You need to activate that version of Python. Here I use the fish command because that's what I use here. And you also see that there is a requirement file that has been created. This requirement file contains the libraries that we need to install. Installing these libraries in Python is pretty straightforward. For that, we use Python pip install -r and then the requirements file. This command will download quite a few libraries. So basically the dependencies that are listed in that file above, and then also, of course, their transient dependencies. And yeah, once that is done, you're ready to go with CDK development. So next to the requirements file, there is also a README file that was created, and then there is the cdk.json file, which is kind of configuration if you want. So one thing that you could configure in there is, for example, the profile that you want to use to provision your application. This profile will be used. This is basically a user or a role that is defined in your AWS credentials file, and this is then being used for provisioning your infrastructure inside AWS. A next important file here is the app.py. This is the entry point of your application. It's not normally going to be a lot of development happening in here because it basically instantiates a class of type IC demo stack. and that's the definition of this class, is where most of your infrastructure as code will land. So you basically create a stack, and then this stack will be referenced in the app. You can also see that there is a test file being created. There is a nice testing framework also part of CDK. You should definitely have a look at that if you want to take this into production. The steps in the life cycle steps of a CDK application. Of course, the bird starts with CDK init. We've done that. Then there is the build step or synthesize step. You can do a diff afterwards and a deploy after that. You can also see that on the top here. So you write code inside CDK in Python files. You execute the CLI. This synthesizes actually into CloudFormation templates. It's really important to realize that CDK is basically taking CDK code, putting it into CloudFormation, and the CloudFormation gets deployed into AWS, where the CloudFormation service will then provision your cloud resources that we have defined in CDK. That's in the last step, the deploy step. So at this point in time, we did the init step. So the next step would be to do the synth step. The synth will automatically do a build step for us. So let's try this out. So again, this will take your infrastructure as code definitions in CDK, so in Python, and will output the CloudFormation template that you can see here in the console. Of course, the console is not the easiest place to look at this, but fortunately, the file was also created inside our project. Here we can see there's a new folder with a new file there, template.json. And this file is basically what you would write yourself if you would write directly in CloudFormation. There's quite a few boilerplate there. There's actually only boilerplate at this point in time because we didn't add anything else to it. But this is the output of a synth command. So let's make something more interesting here. Let's add some construct to our CDK application. Let's just create a Lambda function. That Lambda function is basically a serverless construct that allows you to execute business logic without provisioning any infrastructure. No machine that runs, but also no runtime. You can just upload the business logic in any kind of in the languages that you choose, and then it gets executed inside the environment. So I imported here as lambda underscore because Python already has a lambda keyword and I don't want to override it. And that's my case here. I'll create a new handler, a new object called handler that is of type lambda function. And the function is a construct that takes as an argument to its constructor another construct and a string. So that's a typical pattern that you see. When you create a construct, you need to pass in another construct. That's the parent construct, and then an ID string. So the parent construct in this case will just be the stack, so just be self in this case. But if your application gets more complex, then you can actually have another level of nesting there. The string is just a way internally for yourself to name objects, and will not be literally the same in AWS because it needs to be unique. So there will be some kind of string appended to this. You can also see here that there's quite a lot of tips already from the editor. There's all the code completion that we can see here. So for example, if I want to select the runtime, I can just go and look at the runtime object and see what the runtimes available are for me. So in this case, we'll use Python, use Python 3.9. We'll store the code in a folder, and the way to do that with Lambda is to use the code.from asset, which means it will be part of our code base. We'll call this function, this subfolder Lambda. I'll have to create it later. Right now, just adding it now. And in that Lambda folder, we will create a handler in a file called hello, and the handler will be called handler. So we'll just create a function called handler in a file called hello in a folder called Lambda. You can see here that editor is pointing to some error in our code. I don't really immediately see what the issue is, but it does show you that you get all the support for programming languages out of the box that you are used to, but now with infrastructure as code as a target. So there is something wrong here. I don't know yet what. Let's just try to continue and see where we get stuck. So I'll create a Lambda subfolder. Sorry, I need to create it in the top level. So the Lambda subfolder. Inside that folder, I'll create a file called hello. And hello has to be a Python file. So I'll rename it to hello.py. And inside that folder, inside that file, we'll create a function called handler. This is a function that will be executed whenever the Lambda function is invoked. And it will return a simple map representing an HTTP response. You'll see later why this is, but the HTTP response here is represented. It has a body with a string, hello from CDK, and it has a status code, for in our case, 200. So the handler also takes two arguments, an event and the context. This is if you want to have more, if you want to react on how the Lambda function was invoked. In our case, we'll just ignore these arguments. So with that in place, we have the code and we have the infrastructure definition. We can try a CDK synth to see what happens. And you can see here that we actually have a syntax error. And again, see how nice and how close this is to what you would expect from any normal programming experience. So there's just literally saying, did you forget a comma? Now adding the comma again, doing another synth. And in this output here, you can already see that there's quite a few of extra things that were generated. The command cdk diff will show you the difference between what is being generated now and what was already being deployed to the cloud. Because this is the first time that we will do a deploy, we will actually see everything that will be deployed to the cloud. And as you can see, that's quite a lot of stuff here. So there's a service role. There's also a function there, the Lambda handler, all these things have been generated for us. So we can deploy this now and see how it's going to look like in the AWS console. While this is deploying, let's quickly have a look again at the template file, so the JSON file that was generated for this CDK stack. To confirm first, yeah, okay. You can see there is a lot of elements that were created here, and this is, I think, where you can start seeing the level of abstraction. So if you look to the generated file on the right and the file that we had to write on the left, you can see that there is a big difference, right? So the 4 lines of code generated this much larger file on the right, and then this is basically what CDK will offer you. It allows you to think a bit less about all the individual parts of your infrastructure, think more about it in a sense of the problems that it's solving. It's just a Lambda function. So while this is deploying, you can see here also what kind of things are being deployed. Takes a few seconds. And now we have a successful deployment. So there is a demo stack here being deployed, and that is actually something we could also see in the AWS console. So this is my AWS console, and if I go here into CloudFormation, you can see that the infrastructure as code demo stack was deployed there. It was just created successfully. And if you go inside that demo stack, there is a way to actually see the resources or the individual AWS components that were created. So in our case, there's a Lambda handler there that is a Lambda function. Use the UI here to click and go through the Lambda definition. And the Lambda definition is, of course, a piece of code. And this piece of code should look familiar to you because it's exactly the same code that we wrote in the hello.py file. So this is how it all comes together. This was the file that was written by us and that is now being deployed as the code definition for Lambda. We can test this file. We can test this Lambda function by creating a test event. And this test event will follow a template from API Gateway because we will later in this demo wire up the Lambda to the API Gateway. This is how API Gateway invokes Lambdas. Just save it and try to execute it. And as you can see, the response is, as we expected, that the body is hello from CDK and the status code is 200. So that so far so good, I would say. At the same time, this is not very spectacular, right? So we did create a Lambda function and we did save quite a few lines of code, but at the same time, it's not a fundamental change. I think this is this level 1 construct that I mentioned. This is basically CloudFormation, but in a different syntax. If you want to see a bit more how this abstraction works, we can add something here that is a bit more complex. For example, an API gateway. An API gateway has many more components and it's more high level construct in our CDK. So I'll import it here and then I create a new API gateway, also reference it, save it as an object, as a value here. So API gateway, and again it has a constructor that takes a construct as a parent and an ID. So just again reference the parent stack as self here, and we'll name this this API CDK demo API. Now on this API we want to create a handler. So we basically want to configure it to handle a certain requests. In our case, we want to handle the get methods on the root path, and we want to invoke the Lambda handler once that request comes in. So that's basically the wiring between the API gateway and the Lambda function that we defined before. And you can see here now that we use the Lambda integration to point to the Lambda handler that we defined on line 13. So this is basically how normal programming languages work all the time. You define values and you pass them around. And it's really cool to be able to do this here as well for your infrastructure. So if we run again now this CDK deploy here, so if we now go into the AWS console again, and we go back to the stack, we'll see that not just is there the Lambda handler, but there's also the demo API that we have created, the API gateway basically. You can also see at the output of the command, there was a value outputted URL here. So this is a dynamic value that was generated during the synthesis or during the deployment of your application. And this is the URL where the REST API was deployed. So if we execute a curl command or basically just a GET request on that API, we'll get the hello from CDK. And this is coming from the Lambda function. So what you see here is that we call an API gateway that calls the Lambda function, gets the response from the Lambda function, and returns this to the caller. And to show this, I will just quickly change the response body here, adding 2 exclamation marks, and I will deploy again. Because it's just a small change, it's just a change in the Lambda definition, I will use deploy with the hot swap function. allows us to do this deployment much quicker. Doesn't work for everything. It's not usable for production, but if you're developing and you're working on Lambda functions, it makes it much faster to deploy change. And if we do a curl request again now, you will see that the 2 exclamation marks were added there, so showing that this code actually landed in that Lambda function that we defined. So this brings me to the end of this demo. Let me go back to the slides here, and wondering if there's any questions, Stephen, from the audience.
Thanks. At this time, we don't have any questions. So if you want to continue on.
All right, great. So if you liked and if you think this was interesting, there is quite a few places you can go to learn more about CDK. We'll put some links in the chat. The CDK product page is of course a very good place to start. It has a nice overview. It also has an FAQ with common questions and then some developer resources. There is also a CDK workshop that allows you to get some hands-on experience by following some steps in very well prepared. If you are true with that, there is more advanced stuff there as well, advanced workshops. And then there is the CDK patterns library that I mentioned earlier. So these are all very good places to go to learn more about CDK. So just to repeat here, that if you want to do CDK, you probably want to do you want to version your infrastructure as code, and you want to make sure that you privilege the role that deploys your infrastructure with the least amount of privileges that is possible. You definitely want to investigate testing, and there's different ways of testing CDK applications, and maybe automate this in a continuous integration or continuous deployment pipeline. Look for tools that can spot best practices or security best practices for you, and and that's more or less. These are the steps that you should be able to. These steps should be able to help you getting running with CDK. I've also shared a link a link to a blog post detailing a few of these best practices. I think it's really worth reading through. Thank you very much for your attention. I hope you enjoyed it. That was the end of my presentation.
Thanks, Ward. We do have one final question coming in from JibJab06 again. How do you maintain shared resources?
Yeah, so this is often a challenge for companies. There is one team that develops a construct and they share it internally. Then all of a sudden, another team needs something else added to this. But who's now owning it, and how do you share these how do you make these versions compatible, for example? So I think there's multiple ways to solve this, and depends on your organization. One way is to just copy and not maintain any kind of link. You can just say this is the CDK code that we just copy into the new project, and from there on the development works independently. You can also have a look at how open source projects do it, for example, with a pull request approach. So these are all approaches that can work depending on your environment setup.
Cool, thanks. Do you want to call out, like I said, no other questions, but there was some good chat during the session. Freaky Measures, who is a big fan of the CDK, really likes it. Great, glad to hear that.
Good to hear.
And I suggest, if you're not familiar with CDK, please check out some of the resources that we've shared during this, especially the workshops. They're a good way to learn and to start to dive into using the CDK. So today we looked at leveraging AWS CDK for implementation of infrastructure as code, or is code. And if there's any questions that were not answered, post your questions on repost.aws, where one of our experts can provide you with an answer to your question, and it could become a topic for one of our next shows. If you have feedback, please click on the link to the survey, or you can email us at awssupportsyou@amazon.com. We do want to hear from you. Tell us what you would like to see on the show. And be sure to check out with us next Monday, November 14th at 11 a.m. Pacific time or 2 p.m. Eastern time, where we'll be exploring cost optimization for SAP on AWS workloads. Thank you again, Weird, for taking the time to present today. Thanks for joining us at AWS Supports You, and happy cloud computing.
Thank you.